Everyone, welcome back to the online class of Physics class 10. So previously we learned about the heat and today we'll be learning about the power. Previously means in lower classes we have learned that the rate of doing work is known as power. Now here in electricity basically we don't consider like doing any work because we don't have any kind of displacement of objects. Basically we have displacement of charge. So here power is defined as the rate at which energy is consumed or dissipated by an electrical conductor or by a conductor or an electrical equipment is known as power. So we can write this one as the rate at which electricity is consumed or dissipated in an electric equipment or we can say like device is known as electric power. The rate at which electricity is consumed or dissipated in an electric device or equipment is known as electric power. Now we know the meaning of consume means using of electric charge or electric energy, and dissipated means giving away or providing of electric charge or electric energy. So the SI unit of power means we are talking about electric power, not all the power that we have learned till now. SI unit of power is watt, or we can write as capital W, watt. The power is given by means the symbol is P and it is given by VI. Power equal to voltage into current. So in many devices you might have seen something written on the devices, like in an electric bulb there may be written like somewhat like 12 watt or 9 watt, or in CFL bulbs there can be like 20 watt or 40 watt. In old fluorescent bulb, not fluorescent, sorry, this tungsten bulbs, yellow colored bulbs, there is written 60 watt, 40 or 100 watt. This is the power, means this is the rate or this is the power which will be consumed by any electric device or by the particular device. So P is equal to VI, and this can be further written as I square R. And likewise, we have one more formula, P equal to V square by R. If you look quite carefully, or if you consider it, if you notice, if you remember the formula of heat was VI and T, means voltage into current into time. Here the time is not used, V and I is used, I square R and V square by R. Only the time component is not used. So after we find power for any device, and if the device works for a specific amount of time, that becomes the energy consumed by the device. Like for example, if I have a bulb of 40 watt which is used for 2 hours a day, so here if we multiply this two, means 40 into 2, I will get 80 watt hour. This means this is the energy consumed by the device. So let's look further into it. You can note it down and pause the video and note it down. So moving to the consumption of electricity, means we will see how it is used. So power is given by the formula VI or I square R or V square by R. So this is the formula for power. So example, I have a CFL, for example there is a CFL bulb of rating 20 watt bulb glows for, which glows for example like 8 hours a day. 8 hours. We have to find how much energy is consumed by the bulb. Find energy consumed. So if you need to know how much energy the bulb is consuming, so energy consumed will be the power of the bulb, which is 20 watt, P into how much time the bulb was glowing. So if power, like here we have power equal to 20 watt and the time of glowing is 8 hours. Remember, we don't have to convert this 8 hour into seconds because we need the unit used for consumption of energy basically is used in hour. So this will give us 160 watt hour. 160 watt hour. This is the energy consumed by the bulb. Now this energy, this watt hour is a very small quantity. Means this much energy is very low or very small unit as compared. So to make it convenient for the user or for the consumer, this watt hour when used in commercial purposes, when the energy is used for commercial purposes like our electricity bill. So in this cases the energy is for commercial uses and the watt hour, that unit, is very small. For this the energy is taken as kilowatt hour. For commercial uses, it is written as kilowatt hour. Now, if I am giving like for example 1 kilowatt, so 1 kilowatt hour is equal to 1 unit of energy. 1 kilowatt hour is 1 unit of energy used. If you have an electricity bill in your house, you can see there will be a point or there will be a part where it will be written units consumed. So there will be some number like 20, 24, 18, 10, whatever it may be. So this shows that how much kilowatt hour has been used by your house in the past month. So 1 kilowatt hour gives 1 unit, and how much number is there? For example, if there is 28 unit, so this means 28 kilowatt hour electricity has been used. Now let us see how we can go about this. Means what is the energy of 1 kilowatt hour? 1 kilowatt hour. Now we'll convert this in joule. So 1 kilo means 1000. So 1 kilowatt means 1000 watt. And 1 hour is equal to 3600 seconds, 3600 seconds. We'll multiply this, we will get 36 and 5 zeros, which is 1 second, or just writing as a whole, 1 second. So this is our 36 lakh watt seconds. So this number is very big. We'll reduce it. We'll write it in to the power of 10. So this will be 3.6 into 10 to the power 1, 2, 3, 4, 5, and since I am putting decimal before 6, so 6. 1, 2, 3, 4, 5, 6. 10 to the power 6. And this watt second in short is known as joule. Or you can write capital G. So 1 kilowatt hour is energy equivalent to 3.6 into 10 to the power 6 joule. This is equal to 1 kilowatt hour. So you have to know this part, this conversion part you have to know. Okay, this much. So just one small question related to the power. If you want to write, you can pause the video and write the particular things. So, for example, there is a question: a room uses a bulb. How will we change the question? Just this bulb question we did. Find the power of an iron having voltage having 220 volts of potential, iron running on it, you volt of potential difference at 2 ampere current used for 1 hour. Also find the energy consumed. So just for example, I have given a question that there is the electric iron running on 220 voltage potential difference with 220 volt supply and 2 ampere of current, which is used for 1 hour, or just we can change the time like for 2 hours. We also find the energy consumed. So here power will be V into I. So here V is our 220 and I is current is 2 ampere, which gives us 440 watt. This is the power of the electric iron. Now when the iron is used for 2 hours a day, we need to find the energy. So energy consumed equal to this 440 watt V into T, actually, sorry, not P, it is T. So this gives 440 watt into the time used, that is 2 hours. So 2 hours, which gives us 880 watt hour. Now since we are using or finding this for an electrical equipment, basically for commercial use, basically it is used in a home, so we can leave this as watt hour, or basically better if we convert it into kilowatt hour. So to convert this into kilowatt hour, we have to divide this 880 by 1000. This will give us, it will be kilowatt hour. This will give us 0.88 kilowatt hour. And if you need to find the bill, means this will be 0.88 units, and we will multiply it with the rate of the money. So this is how we can solve questions related to power. There is an example in your book in page number 219. You can try to solve that example related to power. So this much only for the chapter electricity. Thank you.